Now we have a new chapter, that is chapter 4, Determinants. As a unit, matrices and determinants are related, so we are going to deal with matrices also in this chapter. So first of all, what is a determinant? Yeah. So first, since it is connected to matrices, we are going to have some matrix. So let us have a square matrix. Square matrix 1, 2, 3, 4. Okay, this is a square matrix. So what is the meaning of a determinant is that for a given square matrix, any square matrix of some order, so order can be of any integer, right? So for a square matrix of any order n, we can associate a real number. Yeah, you can associate a real number or a complex number, maybe depending on the entries of what is here. So we can, for every square matrix of order n, we can get a number, maybe real or complex, that is called as the determinant of this matrix. Okay, let me write this matrix as A. So what is the determinant of matrix is the real number that is going to be obtained from evaluating this matrix, evaluating the determinant. So at last the number what you get is called the determinant. So first of all, we need to know that only square matrices can have this determinants. Okay, first of all. The second thing is it can be a real number or a complex number. Real number or a complex number. We are not going to deal with this here. We are going to deal with only the real numbers. First of all, we need to learn what is the determinant, how to evaluate the determinant and such things, right? So we have number of orders, right? We have a square matrix of order 1, square matrix of order 2, 3 and such. So in this class, we are going to learn only about order 1, 2 and 3. So 1 is not at all applicable. I'll just tell what is for order 1. So let me mark this and maybe I'll write 3 here. This is just an example. So B is a square matrix of order 1. Therefore only one element is present over there, that is 3. Okay. So since I need to find the determinant of this matrix, so I need to denote something. So how do I denote for a determinant? First of all, I can write it like this. This is similar to the modulus sign here, but you cannot read it as mod A here. It is to be read as det A, or you can write like this also, det A or determinant A or determinant of A, however you can read. So we are going to read it as det A, not modulus of A. So here you have B having an element, that is 3. If I need to find the determinant of this B, okay, it is going to be only this value. Okay, that is very easy. That is the first one. We are going to the second one. Second one becomes a little bit complicated. We have this A, I think. I'll just rub the remaining parts. Right, you have the A now. How do you find the determinant of this? You need to get only one number. Are you going to select any number out of this? No, we are going to do something with this only. Right? So we have a general formula like this. This is A11. This is A21. A12. A22. Okay? How do you calculate the determinant in this case? This is general form. General form, this is the first row, first column term. This is the first row, second column, second row, first column, and second row, second column term. That's how I denoted that A and all. In the previous chapter also we denoted like that only, I think. So if you have a matrix like this, how do you find the determinant of that? For that, we need to do like this. Cross multiplication. So it is going to be A11 into A22 minus A21 into A12. Okay, 2 1, that is not 21. So the determinant is going to be like this. Determinant is equal to A11 into A22 minus A21 into A12. This kind of thing you are going to use for the order 3 also. Order 3 is the most important. It has many applications. So one of the application you are going to learn in this chapter also. So determinant for a square matrix of order 2 will be like this in this format. So we'll have the example here. So if you have the example, first of all need to cross multiply in this format. It becomes like this. So 1 into 4 is 4. So I need to denote it to be determinant of A, not A equal to. Determinant of A is equal to 1 into 4 is 4 minus 2 into 3. 2 into 3 is 6. Therefore the determinant of A is equal to minus 2 in this case. So if I have some other random number, so maybe C, I'll write 1, 4, 4, 6. Okay, I'll find the modulus of value of C. That should be equal to how much? Okay, so it is going to be 1 into 6. 6 minus 4 into 4. That is 16. That is going to be minus 10. The determinant value here is going to be minus 10. So it can be any real number, it can be fraction, it can be some other negative number also, or even 0. 0 is a special case which we are going to learn in a later part. Okay. Next we'll move on how to find out the determinant of order 3 matrix. Okay. Okay. First of all we are going to learn the first method here, expansion by the first row. So one or two methods we'll learn and wind up here. So the first one is by expansion by the first row. So first of all we need a square matrix of order 3. So directly I'll write the determinant form itself rather than writing that bracket and all. So it is going to be in this format, right? It's going to be in this format. So it is going to have A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this determinant we are asked to find out. Okay, now our problem in the second one was directly like this: A11, A12, A21, A22. So first directly we did the cross multiplication, so directly we got that. So somehow we need to convert this determinant of order 3 into a determinant of order 2, so that directly we can apply this and do. Okay, so we are going to learn shortcut method later. So first of all we need to learn the theory part of this. So first of all we are going to consider only the first row. Now I'll just highlight that first row. This is the first row, right? So first row is more important now. Yeah, we need 3 sums because there are 3 columns. We need sum of 3 numbers, right? So first we are going to do something. So there is a general form like this: minus 1 whole raised to this I plus j. I plus j refers to the here 1, 2 and all we have, right? I refers to the which column, which row it is belonging to. J refers to which column it is belonging to. So it is going to be minus 1 whole raised to I plus j into a ij and the determinant corresponding to that. Okay, which will the determinant corresponding to that we'll learn now. So we'll take an example and just explain how we are going to get the determinant of which part and such things. So now we have A11. A11 is the first part of the sum. Okay, minus 1 whole raised to 1 plus 1. 1 plus 1 is 2. So minus 1 whole square, it is going to be 1 itself. So we can just leave that off. So it is going to be A11 only, or A11, right? A11. Then you have a determinant of order 2 here, which is a determinant of order 2. The easiest way, or this way I suggest you to do, is you need to remove the column and the row that is belonging to that A11, right? So remove all the elements that is belonging to that. So you get these 4, right? Those 4 elements you are going to get. So just write that: A22, A23, A32, A33. Okay. Now you know you got an determinant of order 2 here. Directly we know how to do the cross multiplication and go on with the further things. So the remaining things I'm just leaving it for you. I'm just telling how we are going to apply this minus 1 whole raised to thing, and also what is going to be the entry here inside and which is belonging to this row or the column. Okay, next we have the second one. We need to consider minus 1 whole raised to 1 plus 2, because it is a1 2, right? 1 2, therefore it is going to be 1 plus 2 here. 1 plus 2 is 3, minus 1 whole cube is going to be minus 1 only, so only one minus sign is be left out, right? So one minus sign is to be left out over there. Okay, so what is going to be in this is, again we are going to see. My method was to remove this column and remove that row. The thing what is remaining over here is A21, 23, A31 and A33. Okay, that thing I am going to write it here. It is going to be A21, A23, A31, A33. That is what it is going to be. 21, 23, A31, A33. This again we are going to use the cross multiplication, or simply a way of finding out this, right? Yeah, that's it. Next you have the third part. Third part, it is going to be minus 1 whole raised to 1 plus 3. 1 plus 3, because it is A13. 1 plus 3 is 4. Minus 1 whole raised to 4 is positive itself, so you get only positive value. It's going to be A13. And then one more determinant. Okay, if you have A13 here, you remove this column and remove this row. So this 4 elements you are going to get, that is going to form this square, or sorry, the determinant. That is going to be A21, A22, A31, A32, 21, 22, A31, A32. Further, we can use the cross multiplication method and directly find out the value of a determinant. So now we will have an example based on this, right? Sorry, before going for the example, we'll just explain how we are going to expand using the second row. So if you have the second row here instead of the first row, so we need to highlight only the second row now. The general form remains the same. So what it is going to be is more important here. Especially the minus sign that comes in between is going to be the most problematic part when it comes to the second row or the second column. Okay, we'll go to the second row. So first term is A21 and minus 1 whole raised to 2 plus 1. So 2 plus 1 is going to be 3. So minus 1 whole cube is going to be minus 1. So I'll just remove all the things and write one minus sign over there. Right? I hope you can understand, because I have done in the previous one also. So it is going to be A minus 21, and the second part which you are going to get is remove the column, remove the row. So it is going to be A12. Yeah, you remove this column and remove this row. So you have this much. A12, 13, 32, 33, 13, 32, 33. This is the first one. The second one is A22, because it is going to be minus 1 whole raised to 2 plus 2. 2 plus 2 is 4. Minus 1 whole raised to 4 is going to be plus 1. So it is going to be like that only. Then you have the square or the determinant. So for that you will get these terms A11, A33, 11, A33. So because you are removing the second column and the second row, so you are going to get only the corner elements. This is A13 and A31. Then next one you have minus 1 whole raised to 2 plus 3. I is 2 and j is 3. So it is going to be 2 plus 3. So it is going to be minus 1 whole raised to 5. Minus 1 whole raised to 5 is minus 1. So 1 minus sign I am putting here. So next I have only the determinant part. For the determinant part I should remove this and this row. So for that we get A11, A12, A31 and A32. In this format you are going to get. If you add all the three, sum of all the three is given to be the determinant of A. Okay, somehow we can find out. If you get the numbers, it's easy rather than going on using these big variables and all, you get so irritating. So this much is all about this. Even if you use the column, we are going to follow the same thing, right? So if you are going to use the column, you are going to start with A11, go with A21, A31, and you need to follow this I plus J. So one thing you can remember is when you are starting with first column or the third column or first row or the third row, the first one is going to be positive, the second term is going to be negative, and the third term is going to be positive. Okay, you need to put a positive negative sign and all. That's what I'm explaining. For the first or the third row or column, so it is going to be positive first, then negative second, and positive in the third place. So if you have to start with the second row or the second column, then it is going to be negative in the first, positive in the second, and negative again in the third one. That's not all about how to get the determinant of a square matrix of order 3. We have an example now. So a random example. The whole exercise is just about finding the determinant. So I'll just choose so many with zeros, otherwise it's going to be irritating for me. So it's going to be 1, 2, 0, 3, 4, 6, 5, 0, 2. Okay, it is going to be a big number, I think. So rather I'll rub this 5, make it 3. Okay, this much is okay. So for convenience, I'm just going to do with the first column now instead of the first row. Even if we exchange the columns and the rows, that is one of the properties of determinants we are going to learn in the next part. So even if you interchange the rows or the columns, all the rows and the columns, you are going to get the same determinant as the answer. So therefore, even if you start with a column or the row, the determinant will not change over there. So now let me start with the first column. So we are going to start with the 1 itself because it is going to be positive. I told it is going to be first one is going to be positive. It is first or the third column or the first or the third row. So here I am taking the positive for the first one. Then I need to find the determinant of the remaining, that is 2602. Instead of writing that big 2602, or I'll write that first one. This is one example, right? One of these I'll write. Then the second term is going to be negative, right? So minus 0 into determinant of that is 4236. 4236. Then the third one is going to be positive. Then you have 1 3 here. 3 times what is this is going to be 4230. This you need to just calculate. So it is going to be 1 into 2 into 2 is 4 minus 0 into something plus 3 into minus 6. Okay, it is going to be 4 minus 18. It is going to be minus 14 is the answer. Okay, now we have our exercise 4.1 where we have our questions here. So the first question is first and second one is going to be evaluation of what you're going to find out here. So it is a square matrix, determinant of a square matrix of order 2. Therefore it is going to be very simple, not that like a order 3. So it is going to be minus 1, 2 into minus 1, it is going to be minus 2, minus of 5 into 4, minus 5 into 4 is minus 20. Therefore it is going to be minus 2 plus 18, not 18, 20. That is going to be 18 as the answer. Okay, next you have a second part, second question first part. It is going to be like this. So cross multiplication, cos theta into cos theta is cos square theta, minus of 1 minus is there here already. so I need to put one minus here. Then you have minus sine square theta. That is going to be cos square theta plus sine square theta. So trigonometric identity, we directly know it is going to be equal to 1. That was a simple one. Now we have a second part. We have x squared minus x plus 1 and so many things like this. So we are asked to find out the determinant. It is going to be a bit complicated than the other one. So you have x squared minus x plus 1 into x plus 1 minus x minus 1 into x plus 1. So easier method is to take this x plus 1 common outside. X plus 1 I'll take common. So what is going to remain here is x squared minus x plus 1, x squared minus x plus 1 minus of x minus 1. Okay, therefore it is going to be x plus 1 into x squared minus 2x. Yeah, minus x and minus x, so it's going to be minus 2x over there, right? So it is going to be minus 2x. Then you have plus 1, minus of minus 1 is again plus 1, so it is going to be plus 2 over there. So the remaining part is just to evaluate or just go on multiplying that with the thing. I hope you know how to multiply, right? So maybe I'll just try to multiply. It is going to be x cube minus 2x square plus 2x plus x square minus 2x plus 2. Okay, now you have plus 2x and minus 2x, it's going to get cancelled. Then you have x cube, then minus x square plus 2 is going to be the answer for this determinant. Okay, that's what the value of that determinant. Next you have your third question. Third and fourth question is very similar, so I'm going to do only the third question here. So the third question is given, you are given a matrix like A is 1 2 4 2, right? So the question is, we are asked to prove that 4 times the determinant of A is equal to determinant of 2 times that of A, right? So first of all we'll find what is 2A. Okay, therefore 2A is equal to, if I need to multiply, it is going to be like this, or I'll just rub this off. What is 2A is going to be, if you are asked about matrices, when you multiply 2 by a matrix, every element present in that matrix is going to be multiplied by 2. Therefore, what is 2A going to be is 2, 8, 4, 4. Okay, that much is you're going to get. So what is the modulus, not smart, the determinant value of 2A is going to be 2, 8, 4, 4. So it is going to be 2 into 4 is 8 minus 8 into 4 is 32. It's going to be minus 24. Okay, minus 24 we got. Now we have 4 times the determinant value 1 4 2 2. Therefore it is going to be 4 times 1 into 2 is 2 minus 2 times 8 2 times 4 we are going to get 8. So it is going to be 2 minus 8 or 4 into minus 6, or I can call it to be minus 24. Therefore we find out that 4 times the determinant value of A is going to be equal to the determinant value of 2 times the matrix A. This is one of the properties we are going to learn in the next part also. So next we'll move on to the fifth question, where we are asked to find the determinant value of the matrix of order 3. Okay, now we have a fifth question. Fifth question we are also asked to evaluate the determinant. That is the only thing we have learned in this chapter, evaluating the determinant. So the first question, here all the questions are of order 3. So I need to just see how different methods we are going to get just by solving within these only. Okay. So now we have like this. Here you have 2 zeros in this. So I know that I can expand determinant by any row or any column. So for easiness, we are going to opt the one which has maximum zeros, so that we can involve 0 plus 0 and one number remaining. Okay. So since you have two zeros here, I'm going to opt for the second row so that it becomes a shorter one rather than going for the other things, right? So I'll take the second one. So it is going to be this is, if you are starting with the second row, we need to be careful that we need to give a negative sign in the first and the third term. So since I have only the third term, so I need to take minus of minus 1, right? Then we need to find that determinant of that order 2. For that, I need to remove the elements that are present here in the same column and in the same row. So you are going to get a determinant 3 minus 5, 3 minus 1. So rather than writing the determinant again and again, I am just going to do it just by seeing here itself. So because the whole chapter is finding about determinants and such things and all, we are to get used to how to find out all those things and all. So we'll take another bracket inside. It is going to be 3 into minus 5. That is going to be minus 15. Then minus of 3 into minus 1. That is going to be minus 3. Okay, it is going to be 1 into minus 15 plus 3 is going to be minus 12. Therefore, this is minus 12. Okay. Next, you have another number. Here, no other option. Anything will take. Okay, but I will take the second row itself because we have 1 over there rather than multiplying so many big terms around. So we'll take that one. So first of all, we are starting with the first one. So since it is in the second row, first one, we are giving a negative sign over there. So minus 1, I can leave it out. I'll just start with the bracket over there. So if I take this, it is going to be minus 4 into 1, that is going to be minus 4. Then minus 3 into 5, that is 15. Okay, then one plus sign for the second one. Yeah, since it is 1, I can just leave out like that only. So it is going to be 3 in 3 minus 2 into 5, that is 10. Okay, then you have a negative sign because you are going to do the other one. Since it is minus 2, it becomes minus of minus 2, so it is going to be plus 2 over there. Okay, that much we got. Now we need to remove the column and the row. What we are going to get is 3 into 3, that is 9 minus of 2 into minus 4. Since there is a remaining things, 2 into minus 4 is there over there, so it is going to be minus 8. So minus of minus 8 is going to be plus 8. Okay, we'll just see what we're going to get here. So the first one was minus 4 minus 15, that is minus 19. Minus of minus 19 is going to be 19 over there. Okay, then you have 3 minus 10, that is minus 7. Then you have 2 into 9 plus 8. 9 plus 8 is 17. 17 into 2 is 34. Okay, plus 34 we are going to get. So it is going to be, what is the number we are going to get here? So it's going to be a big number. So maybe we'll subtract 7 from 19. We are going to get 12. So 34 plus 12. 34 plus 12 is 46. So 46 is the answer for this. Then you have, this is like this. So since you have in this manner, not in the same row, anything is same. So maybe I'll take one column this time, so for making you familiarizing that. So let me take the second column because it is different when compared to the first and the third one. We knew how to find out through the first one. Here we'll use a second column. So if I take the second column, the first one should be having negative sign. Okay. If it is first one having the negative sign, I need to remove that column and that row. Okay. So you are going to remain with minus 1 into 0, that is 0. Then one more minus. Yeah. Then you have minus 2 into minus 3. Minus 2 into minus 3 is going to be minus of minus is plus. So 6, it's going to be remaining over there. Okay. Then the second term is 0. I need not bother about this sign. So it is 0. The whole term is going to vanish. Right. Now you have a 3. So since it is the third term, I should have a negative sign. Then you have one 3 here. The remaining part is finding the determinant of the order 2 matrix that we are going to get over there. So it is going to be 0 to minus 1 3. So 0 minus 3 is going to be cancelled. So only one 0 is going to remain. Then the second term before that I need to have one minus sign, right? Then you have minus 1 into 2. Minus 1 into 2 is minus 2. Therefore it is going to be plus 2 here. Okay. Therefore the first term becomes minus 1 into minus 6. That is going to be 6. Then minus 3 into 2 is minus 6. So it's going to be 0. Alright. One more thing you can observe in this question is the matrix from which this determinant is obtained is a skew symmetric matrix. Yeah, you can see the 0 terms here in the diagonal, and if you draw the line here and just check the opposite terms, here it is minus 1 1, minus 2 2, and 3 minus 3. Therefore it is a skew symmetric matrix over here. So we can infer that for any skew symmetric matrix its determinant is going to be 0. Okay, we can have something to prove that, but still we can just general statement is for any skew symmetric matrix it is going to have a determinant that is having the value 0. Okay, next we move on to the fourth one. The fourth one is 2 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. Maybe I'll take the third row or the third column. Which one? Third row I'll take now. Okay. So third row is very similar to the first row. First one is positive, second one is negative, and the third one is positive again. So it is going to be 3 into something. 3 into something. So it is 3 into something means you are going to get this. Yeah, that column and that row is going to get cancelled. So the determinant what you are going to get is this much. So it is going to be minus 1 into minus 1, that is 1. Then minus 2 into minus 2 is going to be minus 4. So minus of, here one minus also there, so it is going to be plus 4 here. Okay, next you have your second term here, minus 5. So we need to put a negative sign in front of that. Since it is minus 5, it can become minus 1 into minus 5, that is going to be plus 5. So it is going to be plus 5 into, then what you are going to get here, the determinant corresponding to that is 2 into minus 1. 0 minus 2 is going to get be a 0 only, so it's going to be 2 into minus 1 over there. It's going to be minus 2 here. Okay, so it is 3 into 1 plus 4. 3 into 1 plus 4 is 3 into 5, that is 15. Then 5 into minus 2 is minus 10. So the answer here is going to be 5. That's all about finding the determinant and all. You can be given any question based on that. Okay, we'll move on to the next question in the exercise. Okay, then we have a sixth question. The question you are asked to find the determinant. Maybe I could have left. Maybe I'm doing that. Now we have this thing. So it's a 3 by 3 only matrix based on that only. So any number I'll take. Maybe for the simpler one, I'll take the first row only. Yeah, first row. So I need to start with 1. It's positive here. Then it is going to be 1 into minus 9, that is minus 9, minus of 4 into minus 3, so it is going to be minus 12, so minus change to plus. Then you have minus 1 into 2 into minus 9, that is minus 18. Then you have minus 5 into 3 is 15, so it is going to be plus 15 here, right? Then you have minus 2 into, since you have minus 2 only, I had to put plus over there. Since the number was minus 2 directly, I am not bothered about that. I am just going to put that minus 2 over there. So if I put minus 2 over there, what you're going to get here is 2 into 4. Since I need to cancel that row and that column, it's going to be 2 into 4, that is 8 minus 5. Okay, this much we got. So we can just go on simplifying. What we're going to get is minus 3 over there. Then you have minus 1 into minus 3, that is plus 3. Okay, that much we got. We have to get minus 9, minus 9 plus 12 is going to be plus 3. So this is also plus 3. So plus 3 plus 3. Then you have minus 2. This is going to be 3 here. Minus 2 into 3 is minus 6. So 3 plus 3 is 6. 6 minus 6 is 0. So here you find out that the determinant of this is not a skew symmetric, right? You can just see that the diagonal elements are not equal to 0. Therefore, directly you can conclude that this is not going to be a skew symmetric matrix. And so, but still, you have found out that the determinant of this thing is going to be 0. Okay, this is a special case. So such kind of matrices whose determinant is equal to 0 are called to be singular matrices. We are going to learn in the last part of this chapter. Okay, now we have our 7th question. This is just about doing something. Yeah, go on. Expanding. This is going to be 2 minus 4 into 5 minus 20. So it's going to be 2x into x, that is 2x square. Then 6 into 4 is 24. Okay, then in the left hand side you have minus 18. Then you have 2x square minus 24. Minus 24, we are bringing this side, it's going to be plus 6. So 2x square is equal to 6. X square is equal to 3. X is equal to plus or minus root 3. Okay, next you have one more thing. Here, same thing, go on expanding. 2 into 5 is 10 minus 4 into 3 is 12, that is equal to 5x minus 6x. Therefore, minus x is equal to minus 2, x is equal to 2. Is the answer here. Okay, this is a simple one. You are asked to just solve for x. That's what we had to do. Next question. This is an MCQ question here. You have the question. So, determinants are equal. So, just by finding, just by seeing, you can tell that here you have 2, here you have 2, 18, 18. So, here also x, here also 6, 6. Just by seeing, you can tell that x is going to be equal to 6. So, we need to find, can be some other case for which it is going to be equal. So, we'll just evaluate that. It's going to be x square minus 2 into 18 is equal to 6 square is 36 minus 2 into 18. So minus 2 into 18 minus 2 into 18 all get cancelled. So x square is equal to 36. X is equal to plus or minus root 36, that is going to be plus or minus 6. So now we found out that there is one more, that is when x is equal to minus 6 also these determinants are going to be equal. So therefore, just by seeing, we cannot tell that only 6 is going to be the answer here. Minus is also a possibility over there. So this is going to be the option B. Okay, this is all about finding and expanding of the determinant. Now in the next part we are going to learn about the properties of the determinants. There are several properties, so there are ways to expand this determinant without using the direct method. This is the direct method. We are going to use the properties in the next part to expand and find out the factors of the determinant. Yeah, determinant is just a number, right? So yeah, we need to find the factors of such a determinant by using the different properties. So we can have several types of questions over there. Most difficult type of questions come from there and system of solving. Okay, thank you.